Hello, my name is CJ Moore. I'm an undergraduate research fellow at Missouri State University, and in this video I'm going to show you how to install, configure, and work with the software that we've developed to allow for the creation of classification data sets of Arc-CIs. So to start, what we want to do first is install our package manager. So what we want to do is open an instance of Chrome, and we're going to look up Anaconda download. So go ahead and click on Anaconda Individual Edition here. And then you're going to click this download right here if you're on Windows. If you are running on a different OS, you can click one of these right here. However, I am not going to let this finish because I've already configured my Anaconda. As you can see, it's right there. I don't need to do this, but it's just like any other executable installation wizard. Go ahead and set that up and configure that. And when you're done with that, we can go ahead and start moving on to the next step. So let's go ahead and close that because we won't need that anymore. And once we have Anaconda done, we're going to go over to our search bar here, right underneath me, right here, your search bar, and you're going to look up Anaconda prompt right here. Okay, so now we are working with the command window that's going to allow us to navigate our files and then activate our directory, or activate our environment. So what we want to first do is navigate to a file location where we feel comfortable storing the files that we're going to install from GitHub. So I already have a place saved right here. I'm going to go ahead and copy its directory, move it back down. Then I'm going to type in cd for change directory, \d for drive, and change to the S drive. So now we're working here. And now we can install the code from GitHub. So I'm going to go to GitHub. Now the repository that we're currently using is not the repository that you will get the code from. It's likely that you're aware of the repository where the code is located before you see this video. So just whatever place you've been told to receive the code from, go ahead and take it from that GitHub repository. The one that you know you should be working in. Not this one right here, but this is the one that I currently have the code on. So I'm going to come here and I'm going to press code. I'm going to click this to copy it to my clipboard. I'm going to go back down to the Anaconda prompt. And now I can type in git clone, Control V, and now it is going to clone all of those files to that file location. If we can go back to it here, it's underneath the Chrome. Oh, it's right here. We can see that we've now downloaded this folder. Let's go ahead and open it up. We'll copy its path and go ahead and navigate into it here. CD, copy that path. Okay, so now we are inside the folder that we downloaded from GitHub. So here we can see we have IPy notebook checkpoints, Git, don't worry about these. Debug, we will get to in a different video. Environment, you don't need to worry about. Lib, you don't need to worry about. Git ignore, you don't need to worry about. You don't need to worry about the license. You might want to, well, no, actually you don't need to read this README. But the setup script is important. So now that once we've started this, we're going to run the setup script to configure our environment depending on what operating system we have and various other things. So we're just going to go ahead and run python setup.py, and it's going to run this script right here. That's going to just basically do everything that we need to do before we start working with the GUI. Okay, so we got that done, and we got a conda value error here. Prefix already exists, Arc-GUI. What this is telling me is that this environment that we tried to create in the script, Arc-GUI, has already been created. So that's fine. I've already done that before. You're going to get a different message, but basically what you want to do after running setup.py is run conda activate arc caps locked g under lowercase ui. It is, oh, I didn't type that in right. Okay, see, it will say that if you don't type it in right. You have to type in capital A RC capital G UI conda, like that. Okay, so now as you can see, it is up and running. So we've moved from base, which is the environment on the local machine, to Arc-GUI, which is the virtual environment that we want to be working in. Okay, so now that we've done all of these things, we've done everything that we need to do to set up and configure our environment, and we're ready to start working with this right here, the Arc-CI Training GUI. Now, this thing is an iPad notebook. It's going to be able to launch in any IDE that you use that works with Python or works with iPad notebooks. So Visual Studio Code 2020, PyCharm, Spider. Do not use Google Colab because Google Colab doesn't agree with tkinter and it doesn't get along, so I would avoid Google Colab. But other IDEs should work just fine. So what I'm actually going to do, if you don't have an IDE, you should follow what I'm doing. And just go ahead and type in Jupyter Notebook. And this was installed with Anaconda, so we should be able to run this right off the bat. So it's going to open a file viewer here in the Chrome browser, and I can also run this file here. So I'm going to go ahead and click it. And it's going to open up the Jupyter Notebook here. If you get this message, go ahead and change the kernel to Arc-GUI because that's the one we want to work with. It's already configured. Okay. So now we have our code right here, and we're going to just run it from here. So we can press this right here to initialize it, but I need to populate it first or it's not going to recognize any images. So the Arc-CI Training GUI serves two purposes: cropping images and classifying images of the correct size. When we are assessing images that we want to put into eventually a training data set for use in deep learning, we need to pick image sizes that are optimal for use in deep learning. And that means ensuring that all of our images are size 256 by 256 pixels every single time. And we designed some tools that are going to allow us to take larger images and make them into the correct size. And we'll talk about that here in a minute. But first, I need to populate this read folder. So the GUI has two folders, read and write. Write is currently not here because we haven't initialized this yet. But once we initialize it, it will show up, and we will discuss exactly what is in it. But for now, I want to go ahead and copy these images. You're just going to get images from wherever you will be receiving images from. Then go ahead and take them and put them in the read GUI. And what this allows us to do, it allows the GUI to initialize, starting here, these images and work with them. So let's go ahead and run it now that we have populated that folder. So it might take a second just to run, especially if you haven't ran it before. But you know that it's running when you have a blue quill pin right here at the very end of your taskbar. And you can open it up here. And this is what it looks like. So to start, we're just going to press initialize image. And these buttons right here are going to allow you to go back and forth throughout the image folder and change which image that you're currently working with. Let me work with a different image. So this is the most likely, it's most likely that you start off working with images that are of this size. This is a rather large image. Okay, we can navigate the image using these navigation sliders here in this red box. As you can see, this red box contains whatever is superimposed onto this matplotlib axis right here. So if you change these navigation sliders, you can change what part of the image that you're looking at, and this is going to allow us to create samples from other images. So when we press crop image here, it's going to take whatever is in this box and create a new image out of it. So we can use this to take an image that's, let's say, so many thousand pixels by so many thousand pixels and make 8 or 9 images of the correct size of 256 by 256 pixels. And this is going to be a very effective technique for ensuring that we have images that are of a consistent and uniform size in the data set that we're going to be creating. So we have this box here, and we can crop images. But how can we be sure that our images are of the right size? Well, our zoom parameter here is going to be half of what one side length of this square is. So as you can see, it's 100 now, so this square is 200 by 200 pixels. And as we get closer to the half of 256, which is 128, you can see it starts to get green, which means that we're getting close to where we want to be. When we're at 256 by 256, it turns blue. But notice it's very hard to get it to turn blue here. I have to be very careful, and even then, the image is large enough to where the zoom factor is almost impossible to really get it here from the slider. So if we want to be sure that we have an image of exactly that size, this button right here, Auto, is going to make it blue every single time. This is a very important button that you should stick close to, because not only does it let you check to see that your box is 256 by 256 pixels for the sake of creating new images, but also for checking images that have already been made. This image is 256 by 256, and when I press Auto here, I can be sure that before I go to classify it, it has the right size specifications so that I can pass classifications onto it. So let's go back and look at this over here. So I can move this around. Didn't like that. Okay. So I can move this around and I can crop images from it. Now that we've initialized it, we can look at actually the right folder. So now the right GUI has been created, and it has 3 subfolders: cropped images and masked images and TDS Cocoa. So there are 2 phases to this process. The first one we've already discussed, which is taking larger images and cropping images of size 256 by 256 pixels over and over and over again until we have a folder with many images of that size. The second phase is taking the images that are that size, made in the first phase, and transferring classifications onto their features, and then making masks from those images and training data sets from those images. So that's what we're going to talk about in the next phase. But right now, let's look at the cropped images that we're making. So right now this folder is empty, but if I press cropped image, it's going to take this and make a new image out of it. I'm going to press cropped image here, and here it is. It's the exact same image that we have right over here. And we can do this over and over. I mean, you should do this over and over. You should try to optimize, the amount of images that you can crop from any given image, just to make sure that we can get as many samples of the correct size as possible. There are thousands of pictures of satellite images of sea ice out there, but how many of them are exactly 256 by 256? It's almost impossible for us to just pick out images of that size, so we need to make those images from larger images. So optimizing them by, you should be able to get, it looks like you can get about 9 samples from this right here, and you should try to get as many as you possibly can. So let's say that we've populated this folder full of images of the correct size, right? 256 by 256. And we're ready to move on to the next step. How can we go about that? So what we want to do, since let's pretend that we've only classified images of that size, we want to close this because we already initialized it with certain files in the read folder, and we're going to have to reinitialize it if we want it to do something different. Let's go ahead and delete these files, which are, it's not going to let me do it. Okay, yeah, skip the ones that won't let me do. Apologies. Actually, looks like most of them. Okay, so we'll skip these. We'll go into the right GUI, the cropped images, and we're going to take them and move them into the read folder. Okay, and this looks like it's 256 by 256 as well. So now that we have populated the read folder again, let's go ahead and launch this one more time, and we'll talk about the second phase. So the first phase is very easy. It's very simple. You simply look at the image, you create, you make sure that your box is blue, and then you collect as many cropped images as you can from that. Oop, I just created this again. And then you create as many images as you possibly can. Try to avoid creating duplicate images, but that is how you go about that process. But now we're going to talk about the second process, which is taking the images that we've already created that are size 256 by 256 and then creating training data out of them. So we can look at this, and as we talked about earlier, we can use Auto to check that it's the right size, and once that we know that it's the right size, we can move on to passing segmentation parameters and classifications to each of the segments. So if you look on the right hand side here, you can see these yellow lines drawn around all of these features. These are the segments drawn by the segmentation algorithm that uses these parameters, Gauss sigma and feature separation, to decide where it's going to draw its lines. So if we tweak these parameters, we can change how these lines are drawn and try to get an accurate representation of the image. So that's the first thing we want to do. We want to take an image that is 256 by 256 pixels, and we want to find the ideal segmentation parameters for it. Okay, this looks like a good one for example. So this is a good example because it has an example. It's an example of good and bad segments. An example of a bad segment, one you don't want to pass a classification to, is a segment like this. So why I would argue that this is a bad segment is because it has multiple features inside of it. This is obviously some piece of ice, or, well, I mean, it must be ice, but it's ice underwater, or it's a shadow cast, but it's the algorithm is not recognizing it as its own independent feature. And you know, it probably will if, let's say, we turn some of these parameters up. We might, oh, not this one. We might be able to find, you know, the right, see, we can get it to recognize it here, but see here now we have a problem with these segments. They're not completely homogeneous. So we want to only pass classifications to segments that we think are homogeneous. So for example, this right here, it's not, there's no way you can confuse this for water or for submerged ice. This is obviously ice floating above the surface. So we can pass the ice and snow classification to it. And like this right here, you could probably say confidently enough that this is water. I don't know, you might say that this is a shadow because there is a shadow being cast there. Ice and snow. Ice and snow. You might notice that there are a lot of ice and snow segments here. An important macro, a very important macro to remember if you're trying to save a lot of time in doing this, is holding control will allow you to select as many segments as you want. Meaning that you don't have to spend all that time, oh, I unselected it, going back down to the bottom of the screen to press the classification that you want. You can simply select all of your segments and then pass the classification and essentially segment an image in, you know, less than 2 or 3 minutes per image. So these are techniques that we've added that aim to make this process as effective and as quick as possible. Please reach out to us if you think that we can in any way improve or add any functions or methods that is going to make this process easier. But yeah, let's say we're going to use this mask right here. Let's say we've classified hundreds of these images and we're done and we're ready to move, we're ready to stop, okay? So if there is, right here, it's going to tell you what file is uploaded to it, what training data set it's currently appending to. If you don't have one, it's okay to just press save. It's going to create one and name it for you. So we'll go ahead and do that. Admittedly, the saving function is slow. We don't quite know of a way to do it quicker just yet because the saving function does have to do a lot of encoding. It has to encode each and every individual segment and then write the segments to a data set and create a data set. There's a lot of things that need to be done. So if your GUI is taking too long, which it looked like it wasn't all that bad that time, but if it takes too long, don't worry. We've tried to get it to crash doing the save functions. We haven't been able to do it yet. It's just writing. It's going to take a second. But don't rush it, and if it says it's not responding, just give it a second. If it takes a while, you know, maybe it did crash, but it's likely that it doesn't, and it's just taking a while because it does take a little bit of time sometimes, especially if you classified a lot of information, so be patient with it. But once we've done that, we've talked about how to initialize images and how to, you know, navigate the image folder. We've talked about how to use this box to move around the image and how to change, you know, the zoom parameter to see how big that is. And yeah, I think when you lock it into auto, it has a hard time leaving auto, but that's okay because we usually want to stay in auto. We've talked about how to save data. We have not talked about how you can select a segment and then press next segment if you want to skip it. Again, remember, if you are not confident with the classification, don't pass a classification. We've talked about how you can press crop image to create a copy of this image and put it into the cropped image folder. And we've talked about how you can pass classifications and change the segmentation parameters. So now we're going to look at the data that we have created. So let's say we're done here. We created some masks. We created this mask right here. So this is our classifications. As you can see here, we have encoded these colors onto this image and imposed them, and now we can use this to train an algorithm. This is not very visible. We may need to pick a different color for this. That will come later. So, and we make masked images, and we also make Coco training data sets. So you can go ahead and open this up. It's a JSON file extension. You can open them in most IDEs. VS Code works just fine. That's just what I'm going to be using. So there are three JSON folders are essentially like dictionaries. There are three dictionaries in this file. Images, annotations, and categories, which is all the way down here. Categories is very simple. It's non-mutable. It's just these things right here, the different classifications that you can pass a segment and then their corresponding ID. If we go up here, images is simply the images that we've classified on. So this is its image name. Because we cropped it, we gave it our own universally unique ID, which is going to help us identify it if, let's say, we're looking through our data set and we have an image that is not 256 by 256 pixels. The usefulness of having height and width here and then respectively size and counts is going to help us check and make sure that we have images of the correct size. You don't need to go through your Coco dataset and make sure that your images are the correct size, but if you suspect that you've cropped one or classified one incorrectly, you can check it out here. And then the counts is essentially the segments. It's this is the segments encoded in run length by run length. It's essentially the run length of the pixels, where they are and are not located. So that isn't super important to you as a user. Just know that this is one of the most important data keys, and we need to preserve it. And yeah, that is about it. In the next video, I'm going to discuss the view Coco in the debug. This right here, this is another program that we're going to use to look at the Coco data, analyze it, append to it, delete from it, see the masks in a different light, statistically analyze it. There's a lot of things that View Coco is going to allow us to do that we can't necessarily do in the Arc-CI Training GUI because they have different functions. But yeah, I'm going to probably call the video there, and in the next one we will discuss how to work with View Coco.